We're going to talk about horizontal and vertical stretches and compressions. So this is a root function. Okay. Quickly, the way to draw this is we start at 0, over 1, up 1, then jump over 4, up 2, over 9, up 3. The reason we've done that, and we're only going to do the positive values right now, okay? And the reason we've done that is because essentially what we're doing is we're plugging in x values. You can think of it like a table. Let me draw a quick table down here, like an xy table. And we've plugged in values. When x is 0, so when we plug 0 into here, the root of 0 is 0, so that's one of the coordinates. We plug 1 in, well, the root of 1 is 1. And then the root of 2 is an odd number, so we actually try to find whole numbers. So 4 and 9 are easy numbers to root, right? So when we talk about that, square root of 1, that gives us 1. Square root of 4, well, that gives us 2. So we go over 4, up 2. And then square root of 9 is 3. So we go over 9 when x is 9. And the y value is 3. So that's just a quick way to draw this function. Okay, so we have our coordinates. Now we're going to talk about A, which deals with vertical. So we're talking about up and down here. Okay, vertical stretches and compressions. So I'm just going to draw a line down here so we have an idea of what we're talking about. Okay, so we're talking about going up and down with this. So we're going to look at this function here. And depending on what A is, if A is a value larger than 1, we're going to get a vertical stretch, okay? And that idea is, I guess we'll do it with different colors of the lines. We'll do this one with a red one. Here's our original line. So imagine it's attached to that. And what ends up happening is we're pulling that line farther up. Okay, so think of it like this. And what will happen to this shape is it'll pull up. So it'll go up higher, which is intuitive. And actually, I'll do it in red. That's pretty good. So you can tell that it's being pulled upwards, okay? It's being stretched when the A value is greater than 1. When the A value is less than 1 but greater than 0, because negative makes it flip, okay? So we can kind of talk about negative after. We'll do this in green, actually. 0, 1. When it's like that, it's actually a compression. So imagine we start here, and our line, actually, green, goes like this, okay? So what ends up happening is we have that same shape, but it's lower down now. It's been vertically compressed. Okay, that's the idea with a vertical stretch and compression. You're grabbing something, pulling it up like an elastic, or squishing it down. Does that make sense?
Yes.
Yeah? Okay. Horizontally, same shape here, and actually we'll be able to zoom in for this one. Could have zoomed in the whole time. Okay. Over 1, 4, 9, and 3. Okay, so here's our original again. But this time, we're talking about root x divided by k. Okay. What's happening is these are opposite, and I should have written them down. When a is greater than 1, it's a stretch. Okay. And when it's less than, it's a compression. Actually think of these as opposite. When k is greater than 1, it's actually a compression. So I want you to think of it like this. We have a vertical line here. Black. Okay, good. And we'll draw it like this. So our line is now vertical opposed to where it was horizontal before. And that's why, because we're squishing from left and right instead. So what ends up happening here is we get, I need a different color. Blue, good, blue's a good color. When k is greater than 1, we get a compression. So we get our line here. And it's actually been compressed. So it's been pushed inwards, you could say. Okay? So when it's been pushed inwards, we get something that, in the other ones, it gets compressed downwards. In this one, it kind of goes like this. Okay, it's been compressed. It's getting squished inwards compared to before, where it kind of looks like that. Okay, so the compression is pushing it in, and then vice versa. If we have, we'll do a purple line here. if k is between 0 and 1, so if k is less than 1 but greater than 0, I should have done that in purple. Okay, it's being stretched. Okay, it's being vertically stretched, so pulled that way. So what ends up happening is we get something like this. That's going much longer than before. Okay, so it's being pulled and pushed. So depending, and because they're opposite of each other, if k is a whole number, they kind of almost produce the same things if you notice. This red one is similar to our blue one here, but the red one deals with a vertical stretch, and the blue one actually deals with a horizontal compression. So different terms for them. Okay, and if you remember, compression brought it in. Yeah, that's fine. So yeah, we brought it in, it kind of went like that. And then the other is vice versa, compression. Here we're kind of brought one that looked like it's going down more, is actually considered a horizontal stretch. Now these aren't drawn perfectly, like their points aren't drawn perfectly, and we didn't have values for them, right? Really, we should have like looked for the blue value here and the purple value out here. But that's the idea. They kind of create the same types of movements, they're just called different and have to do with different numbers when we're talking about A and K. Does that kind of make sense for vertical stretches and compressions?
Yeah.
Yeah?